So these ones on the front, you're doing a derivative. That's what d dx means, derivative with respect to x. It's instructions that mean that. A derivative of an integral. A derivative and an integral undo each other or cancel out, so to speak. So basically, the only way you're going to mess these up is if you like do anything, okay? You're going to take this 9x and plug it in for t. But because it's more than just x, there will be what rule that gets a chain rule. So you have to chain on the derivative of 9x. I usually just go ahead and do that first. You could tack it on at the end with that little chain rule dot if you want. But what's your derivative of 9x? Yeah, 9. And then you just take the 9x, and plug it in. Not cosine, though. That's it. Don't even put a plus c. I'll have to mark that wrong. Because what's the derivative of a constant? 0. So you don't write anything. That's it. All right, same thing for this one. We're going to chain on the derivative of 5x cubed, which would be what? Yep, 15x squared. Okay, good. And then you're going to just take that 5x cubed and plug it in for t. That's it. That's it, Miss Cole? Yep. Now this one has a variable on the upper and lower boundary, so we're going to do upper minus lower. So you're going to plug in the x minus 5. That's your upper boundary. Minus, and then you're going to plug in just the x. This one I do want you to work out because it's just algebra 1 basic stuff. And also a lot of things cancel, so I want you to see that. I'm not going to talk you through these steps because that's going to be annoying. Everybody just go ahead and work it out, and let's make sure we all get the same thing. So like do your distributing and your canceling out. You should get -10. Yeah, we did upper boundary minus lower boundary. So I took the x minus 5 and plugged it in for t. This is like your upper boundary. Minus, and then I did just x, which is the lower boundary. And then we just did some algebra. All right, this one, there's not even a chain rule. You're just going to take x and plug it in. So 3x to the 4th plus 7x. This one also doesn't have a chain rule. You're just going to plug x in, except what? Why is it negative? It's on the bottom. If you want to see, two ways you could think of that. The first way is, oh, they got reversed, so it means opposite. That's kind of how my brain does it. The other way you can think of it is upper minus lower. And what's the derivative of 9? 0. So you could think of it as nothing minus e to the 7x. So however your brain wants to compute that. But if the variable is on the lower boundary, you just put a negative in. Yeah.
Number 3, why do we not put a negative?
Because well, there is a negative. It's right here. It's just the upper boundary wasn't 0. See how in this one it would have been nothing? The derivative of 9 is nothing. That one had a variable in it, though, so there was more to that one. We just did upper minus lower because they both had a variable. All right. And then here's where we take it and put it together and actually like sort of do something. I don't really, be honest with you, I don't really like problems like those ones we just did. There's not really anything to them. Here, this is actually like the meat and potatoes of like the concept that we're doing. So g of x is your accumulation function. Where is the accumulation starting? So if you want to make a note of -3, maybe like draw an arrow towards that or circle it or something, it doesn't start at 0. Sometimes it does if they started at 0, but you just have to be aware of, where it's starting. And the first thing that we're going to do is the derivative of that. So using what we just learned on the other side of the paper, if you do g prime, you just take this x and plug it in, you get f of x, which is this graph. This is your derivative graph. So what I would like to do is go through and slice this all up just to start with so that we have all of our areas. First shape is a triangle. How do you get an area of a triangle? Yeah, 1/2 base times height. The base is 3, the height is 2. I wrote that out so you can all see it. If you can do that in your head, you don't have to write that. It comes out to 3. Semicircle is perfect. And what's our radius? 3. So that would be 9/2 pi. 3 squared is 9. You want half of that. And then this last triangle here, again, 1/2 base times height. The base and the height are both 3. So that would be 9/2 or 4.5, except it's negative because it's below sea level. So I'm going to write negative 4.5 in there. If you want to just do that right off the bat, they will put this on the free response. There will be one where you get this accumulation function and you have a derivative graph. And I don't know which parts of this they're going to ask you. That's why I do all of it. But any of this is fair game. It will be there 100%. Okay. Critical points. Does it say justify? No. So let's just state them. There are 3. Can you look at this graph and tell me what they are? Good. -6, -3, and 3. Let's just verbally do a justification. It would be because G prime equals 0 there. Okay. Increasing and decreasing and justify. Okay, this one's going to be a sentence. G of X is increasing. All right, let's look at our sticky note. I know mine says F and F prime and F prime prime, but pretend it says G. It doesn't, the letter of the alphabet doesn't really matter. You're answering questions about this one, but you're looking at this one. Okay, so increasing is where the graph you have is positive. That means above sea level. So G of X, not the graph you're looking at, is increasing from -6 to 3 because G prime is positive there. And then see if you can write the sibling statement. It would be G of X is what? It's decreasing everywhere else for the opposite reason. So 3 to 6 because why? G prime is negative there. And remember, they will not take it. You have to say G prime is your source. That makes sense. I always try to relate it to like English class. If you're citing a source, you can't just say that guy. Like you have to say his name, right? Like because like someone told me, you have to say who it was. Okay. Relative maximums or minimums. These are the points you want to look at. It can't be -6 because that's an end point. It's not relative to anything. So it can't be that one. This one does not actually give us a relative maximum or minimum either. Why not? Yeah, there's no change there. So stays it, I said it. G prime stays positive there. So we don't have to mention that one. This is the only one we're going to have to write a sentence about. Is this the location of a relative maximum or minimum? Which it's one or the other. Okay. Positive to negative is maximum. Okay, so we're going to say G of X has a relative maximum at X equals 3 because G prime changes from positive to negative there. Now that's all I'm going to ask you to do, but just as a heads up, sometimes they ask you to write a sentence about each critical point. And so you would also have to write a sentence about this one. And you would say, G of X has neither at X equals -3 because G prime doesn't change sign there. Perfect. Okay. Absolutely. Oh, question. I'm not going to ask you that. I just brought it up verbally because sometimes they want a sentence for each critical point.
Could you say that like on the actual positive?
Yes, the only thing I say don't do is some people put a plus sign for positive and a minus sign for negative. Don't do that. They won't take that, but you can abbreviate everything else. Yeah. Well, I actually didn't even get there yet. That's going to happen in this problem, so that didn't come up yet. So, but I'm glad you're thinking of that. And the answer to that question is sort of because they said so. Like that's where the problem said so. I know that's a really crap answer, but that's where they started it. So now when we get to some word problems today, it'll make sense in the problem. For example, and this is why I actually like the word problems better. I know I'm going off on a tangent here. You're like, we hate you, Ms. Cole. The word problems are actually easier because, for example, like where your accumulation starts will make sense. This one's -3 and it's completely arbitrary. It's because they said so, right? But if you're doing a problem and it's like how much water accumulated being poured into something from 3 o'clock to 9 o'clock. Well, your accumulation starts at 3, right? You would have an integral from 3 to 9, and then it makes sense because there's a word problem. This is very abstract and dry. Like it's, yeah, there's like, Yeah, it'll make more sense when we have a story associated with it. All right, what is our test for absolute? Candidates test. So who are our candidates? Critical points and endpoints. Good. So -6, -3, 3 and 6. That's weird. Now this is where it's important that your accumulation starts at -3. So to do -6, just watch me point to it. I'm gonna have to keep moving the paper up and down. If we accumulate from -3 to -6, we went backwards, so it's -3. Good. This one's an easy one. If you accumulate from -3 to -3, you have accumulated precisely nothing. That's like, how far did you travel from 2 p.m. to 2 p.m.? Nowhere, right? All right, now we're going to go from -3 to +3, which is 9/2 pi, 9 pi over 2, whatever. And then all the way to 6 would be 9 pi over 2 minus 4.5. Now we have to figure out which one is the biggest and which one is the smallest. So in your mind, I want you to think of pi as being 3. We're just going to approximate. 9 times 3, 27. Half of 27 is 13.5. Do not write 13.5. That's not the answer. We just did that so we can figure out which one's the biggest and the smallest. Now this one would be 13.5 minus 4.5. So that's approximately 9. So which one's the biggest? Absolute maximum is what? 9 pi over 2 at x equals 3. That's why we write both though. Sometimes they ask you for the maximum. Sometimes they ask you for its location, which is usually a time because it'll be a story problem. So they'll say, at what time is there a maximum? If all you give is that, you don't get the points. So write the whole thing. If you write the whole thing, you'll get it every time. All right, and the absolute minimum is -3 at x equals -6. And the chart is your justification. All right, inflection points. Let me look at my sticky note. Inflection points is a change in concavity. That's increasing to decreasing or decreasing to increasing for the graph that we're looking at. This is the annoying one. All right, so what have we got? X equals, there's kind of a lot of them. -4, -3, and 0. All right. Because G prime changes from increasing to decreasing or decreasing to increasing there. No, you can say either. Like that is acceptable. You want to be like a purist about it. So you would say -4, it would take forever to write it because G prime changes from increasing to decreasing there. -3 because G prime changes from decreasing to increasing there. No, it's a timed test. Don't do that. Okay. This covers it. That's bad enough as it is. All right, concavity. So we're going to say G of X is concave up. Here's my sticky note. Concave up is where the graph you're looking at is increasing. So where is that graph that we're looking at increasing? From where to where? -6 to -4 union. -3 to 0. And that's actually it. Because G prime is increasing there. And then your sibling statement, G of X is concave down everywhere else for the opposite reason.